Jupiter looks like a planet you could land on. From a distance, it appears solid, beautiful, and almost peaceful. A giant striped world floating in the darkness of space. But if you somehow fell toward Jupiter, you would discover something terrifying. There is no ground waiting for you. No mountains, no oceans, no rocky surface, no place to stand. You would fall through clouds, storms, crushing pressure, liquid hydrogen, and eventually into an environment so extreme that the normal rules of human experience stop making sense. And if you stay until the end, you'll hear one strange fact about Jupiter that sounds impossible, but is actually true. Welcome to the Cosmic Perspective. Today, we're asking one simple question. What would happen if you fell into Jupiter?
To understand what would happen, we first need to understand what Jupiter actually is.
On Earth, we are used to planets having surfaces. We have land, oceans, mountains, deserts, and a solid crust beneath our feet. Even Mars, Mercury, and Venus have rocky ground. But Jupiter is different. Jupiter is a gas giant. It is made mostly of hydrogen and helium, the same basic elements that make up most of the Sun. That's why Jupiter is sometimes described as a world that almost became something more. Not a star, but a huge planet built from the most common material in the universe. When you look at Jupiter through a telescope, you are not seeing a solid surface. You are seeing the tops of enormous cloud layers. Those colorful bands are not land. They are fast-moving streams of gas, clouds, storms, and atmospheric layers moving at incredible speeds. The bright zones and darker belts are caused by powerful winds moving in opposite directions. Jupiter rotates extremely fast, completing a full day in about 10 hours, even though it is the largest planet in our solar system. That fast spin helps stretch its clouds into long bands around the planet. So if you were falling toward Jupiter, the first thing to understand is this. You are not falling towards solid ground. You are falling into an atmosphere that gets deeper, denser, hotter, and more violent the farther you go.
Imagine your spacecraft approaching Jupiter.
At first, the view would be breathtaking. The planet would fill the sky. The great red spot would appear like a giant eye, and the curved bands of clouds would stretch from horizon to horizon. But beauty is not the same as safety. As you entered the upper atmosphere, there would be no clean line where space ends and planet begins. Instead, the gas would gradually become thicker around you. At first, you might pass through thin layers of hydrogen and helium, then clouds of ammonia crystals. Deeper down, you may encounter darker clouds made from more complex chemicals. And below that, clouds where water may exist under extreme conditions. But you would not be floating peacefully. Jupiter's atmosphere is filled with powerful winds, lightning, turbulence, and storm systems larger than entire countries. Some storms on Jupiter can last for years. The Great Red Spot has existed for centuries, and although it has changed over time, it remains one of the most famous storms in the solar system. Now imagine falling into a storm system so large that Earth itself could almost disappear inside it. At this stage, if you were somehow protected inside an indestructible suit or capsule, you would feel the pressure rising. Slowly at first, then quickly. On Earth, pressure increases as you dive underwater. The deeper you go, the more the water presses against you. Jupiter works in a similar way, except you are not diving into water. You are falling into a deep ocean of gas that gradually becomes denser and denser. Soon, the pressure would become deadly. Your body is designed for Earth's atmosphere, not for a world where the air itself becomes a crushing wall around you. Without protection, you would not survive for long. The pressure would compress your body. The temperature would rise. The chemical environment would become hostile. Breathing would be impossible. But let's imagine, for the sake of the journey, that you are protected by a fictional spacecraft strong enough to keep going. What happens next is even stranger.
As you continue falling, Jupiter becomes less like a sky and more like an endless ocean.
The clouds above you disappear into darkness. The sunlight fades. The atmosphere grows thicker. Winds roar around you, but at this depth, the word wind hardly feels strong enough. You are inside a planet-sized storm machine. Jupiter's fast rotation, internal heat, and massive size create some of the most extreme weather in the solar system. The planet gives off more heat than it receives from the sun, meaning it has its own internal energy source helping drive its atmosphere. The deeper you fall, the more the pressure increases. Hydrogen gas starts behaving differently. Under enough pressure, gases no longer act like the air around us. They become compressed into strange, dense states. Eventually, the hydrogen around you becomes so compressed that it acts more like a liquid. This is one of the most mind-bending things about Jupiter. It may contain the largest ocean in the solar system, but not an ocean of water, an ocean of hydrogen. Imagine descending into a world where the atmosphere slowly transforms into a deep, dark, crushing sea. There is still no surface, no ocean floor, no beach, no solid place to land. Just a gradual transition from gas to liquid under pressure so intense that normal human intuition breaks down. And even deeper, something even stranger happens. The pressure becomes so great that hydrogen may turn into metallic hydrogen. This is hydrogen under such extreme pressure that it can conduct electricity, almost like a metal. This metallic hydrogen is thought to be one reason Jupiter has such a powerful magnetic field. So now, your falling spacecraft is not just surrounded by dense fluid, it is entering a region that may behave like a planet-sized electrical machine. The temperature is rising. The pressure is becoming unimaginable. The radiation environment around Jupiter is already dangerous, and deep inside, conditions are far beyond anything a real human-made spacecraft could survive.
At this point, you might be wondering, surely if you keep falling long enough, you must eventually hit something. A core, a floor, a center. But Jupiter does not work like a rocky planet. On Earth, we have layers: atmosphere, crust, mantle, outer core, inner core. There are clear boundaries between air, ground, and deeper rock. Jupiter's layers are more gradual. You don't fall through the clouds and then suddenly hit a surface. Instead, the gases become denser, the pressure increases, and the material around you changes state. It is less like falling from the sky onto the ground, and more like sinking into an atmosphere that becomes an ocean, then becomes something even more extreme. Scientists believe Jupiter may have a core deep inside, but it may not be a neat, solid ball like people often imagine. It could be mixed, diluted, or partially blended into the layers above it. The deeper structure of Jupiter is still one of the great questions planetary scientists are working to understand. This is part of what makes Jupiter so fascinating. It is not just a bigger version of Earth. It is a completely different kind of world. If Earth is a rocky island with a thin atmosphere wrapped around it, Jupiter is more like an enormous gravitational well, filled with gas, fluid, storms, pressure, heat, and hidden layers. So if you fell into Jupiter, you would not land. You would be swallowed. The planet would not offer a surface. It would simply become denser around you until the conditions destroyed whatever was falling.
Now let's ask a more realistic question. Could a spacecraft survive falling into Jupiter? The answer is, not for long. Real spacecraft have visited Jupiter, but they do not land on it. They fly past it, orbit it, or study it from a distance. NASA's Galileo mission sent a probe into Jupiter's atmosphere in 1995. That probe did not reach a surface. It entered the atmosphere, collected data for less than an hour, and was eventually destroyed by the intense pressure and heat. That tells us something important. Even a machine built for space exploration could only survive a short time inside Jupiter. NASA's Juno spacecraft, which has been studying Jupiter from orbit, has to deal with Jupiter's intense radiation environment. Jupiter's magnetic field is incredibly powerful, and the planet is surrounded by belts of charged particles that can damage electronics. So a spacecraft falling directly into Jupiter would face several deadly problems. First, radiation. Then atmospheric entry heating. Then turbulence and violent winds. Then crushing pressure. Then rising temperature. Then deeper layers where hydrogen behaves like liquid and possibly metallic material. At each stage, survival becomes less realistic. A spacecraft could be designed to go deeper than previous probes, but not all the way through. Jupiter is simply too extreme. And here is the strange part. Falling into Jupiter is not like falling into a bottomless pit. It is worse. A bottomless pit is empty. Jupiter is full. It is full of material that becomes heavier, hotter, denser, and more destructive the deeper you go. Gravity pulls you inward, but pressure fights back from every direction. Eventually, you would be crushed, melted, vaporized, and mixed into the planet itself.
So what would happen if you fell into Jupiter? First, you would approach one of the most beautiful objects in the solar system, a giant world of swirling bands, storms, and color. Then you would enter the upper atmosphere, where there is no solid surface, only layers of gas. You would fall through clouds of chemicals, powerful winds, and storms larger than anything on Earth. The pressure would rise, the temperature would increase, the atmosphere would thicken around you. Deeper down, hydrogen would stop behaving like normal gas. It would become dense fluid. Deeper still, it may become metallic hydrogen, helping create Jupiter's enormous magnetic field. You would never stand on Jupiter. You would never reach a normal surface. You would simply fall deeper into a world where the pressure and heat become so extreme that survival is impossible. Jupiter is a reminder that the universe does not have to match our expectations. From far away, it looks like a planet, but up close, it is something much stranger. A massive, beautiful, violent world without ground. And now, here is the fact I promised at the beginning. Jupiter is so massive that it does not orbit the Sun in quite the simple way we usually imagine. In reality, Jupiter and the Sun both move around a shared center of mass called a barycenter. And because Jupiter is so huge, that point is actually just outside the surface of the Sun. Think about that. Jupiter is not a star. It is not even close to becoming one. But it is so massive that it makes the Sun wobble. That is the scale of the king of planets. A world with no surface, a storm larger than Earth, an ocean of hydrogen, and enough gravitational influence to tug the Sun itself. That is Jupiter. And that is the cosmic perspective. If this journey changed the way you see Jupiter, hit the like button, subscribe to The Cosmic Perspective, and join us as we explore the universe, one impossible question at a time.